So the next topic is again related to derivatives, but here we will change the derivative with respect to another variable. Like before, we were taking derivative with respect to, this is called with respect to x. Like if we were given function fy equals to f of x, then we were taking derivative dy by dx. Dy means we were taking derivative with respect to x. Now related rates, the word rates means time. This word rate means time, so it means we will take the derivative with respect to time. For example, if you are given y equals to x plus z, we will take its derivative with respect to t, so it will become dy by dt dx by dt and plus dz by dt. Now, why do we need to study related rates? For example, a university student is concerned that the rate of their increase in financial aid is lagging behind the increasing cost of tuition and fees. So a renter is concerned that his rent is increasing faster than his take home pay. So when we compare the rate of increase of two different things, normally we use related rates. Similarly, an automobile manufacturer wants to predict how much an expected increase in a car loan interest rate will decrease her rate of sales. And similarly, this is another example of related rates. In each of these situations, there are two quantities that are changing with respect to time. As I said, rate related to time. So the study of related rates provide a method for determining the precise relationship between the rate of increase of two quantities. We begin by examining related rates with an example where the two quantities are distances and the two rates are velocities. For example, a 26-foot ladder is leaned against a wall. The ladder slips and the top of the ladder begins to slide down the wall. As that happens, the bottom of the ladder slides along the floor away from the wall. As the ladder falls, the distance from the floor to the top of the ladder and the distance from the wall to the bottom of the ladder are both changing. Now, at what rate they are changing? If the top of the ladder slides down the wall at 2 feet per second, at what rate is the bottom of the ladder moving away? Bottom of the ladder, we are denoting the distance of bottom of the ladder from the wall with x. So at what rate? So it means that at what rate x is changing, dx by dt. This is what we want to know when the bottom of the ladder is 10 feet away from the wall. So as shown in the graphic, we let x be the distance from the wall to the bottom of the ladder and let y be the distance from the floor to the top of the ladder. So in that case, we use the Pythagoras theorem, like x plus y square equals to 26 square. Now we want to know dx by dt, and if we differentiate it, like our function is x square plus y square equals to 26 square. If I differentiate x and y with respect to t, derivative of x will be 2x. Now derivative of x will be dx by dt. Similarly here y, derivative of y will be 2y, and then derivative of y will be dy by dt. Derivative of constant is 0. So this is how we get 2x times dx by dt plus 2y times dy by dt. The rate dx by dt and dy by dt are related through this derivative results. This results confirm that this is a related rates problem, as we have dx by dt and dy by dt, and we are given when x is 10 feet, we need to find what is dx by dt, and we are given that the height is decreasing. When ladder is moving away, this height is decreasing, so that is why here we have negative sign. So dy by dt is minus 2. We will substitute the values into this equation, and also we are given when initially height was 24, So we will substitute the values. We have x, we have y equals to 24 when we substitute x into this equation. And after substituting all the values like x equals to 10, y 24, dy by dt is this, we can get what is dx by dt, that how fast this is changing. Normally we follow these following simple steps. Sketch a figure if helpful. Identify all relevant variables including those whose rates are given and those whose rates can be found. Express all given rates and rates to be found as a derivatives, and I added derivatives in terms of dt. Find an equation connecting the variables identified in step 2 and take the derivatives, implicit derivatives, and find out the unknown rates. Solve the derivatives that will give the unknown rates. For example, suppose that a moment of a westbound plane traveling 120 knots is 120 nautical miles from an airport. A northbound plane traveling at 160 knots passes directly over the airport. How fast is the distance between the planes changing 1/2 hour later? Assume that the planes continue at the same speed and direction. One plane is moving in this direction, the other one is moving in this direction. So in this way, if W and N represents the distance from the airport from the westbound and northbound plane respectively, then this is the equation. W square N square equals to the distance between them. And since the westbound plane is traveling 120 knots, so dw by dy is 120, and dn by this should be, I think, t. dn by dt is 160. So after 30 minutes, its located distance is 80 nautical miles north of the airport, headed away from the airport. At the same time, the westbound plane is located a distance of 60 nautical miles, and then we can substitute n and w into this equation. We can get what is d and at what rate d is increasing or decreasing. We differentiate this equation and we can get d by dt, and you can see we can substitute all the values and we can get d, capital D by dt. We take another example. Suppose a point is moving in a circular path centered at the origin and radius is 5. Like the radius is 5. The graph has an equation like x square plus y square equals to 25. So this is an equation of circle. So this is the point which is moving around the circle. When the point is located at this point, minus 3 and 4, its x coordinate is increasing at the rate of 0.5 unit per second, x rate. So it means that dx by dt is increasing, so it is 0.4. How fast is the y coordinate changing at that moment? How fast its y coordinate is changing? So we will differentiate it dx over dt 2y dy by dt equals to 0. You can substitute x equals to, this x is 5. You can substitute here, you can get y, and here you can see we need to find how fast y is changing. So dy by dt, divide both sides by 2, you will get, substitute x equals to minus 3, y equals to 4. This point dx by dt is 0.4, so you will get dy by dt. So dy by dt is 0.3. Now we solve a problem related to the business. The problems which we solved before, you don't need to worry about them because those were purely mathematical problems. Now we solve mainly problems related to business, and from exam point of view, these are the things which you need to know and you need to pay more attention on this. Suppose a company manufacturing flash drives, determining that their cost, revenue and profit equations are as it is, where the production output in 1 week is X flash drives. If production increases at the rate of 500 flashes, X is representing number of flashes and this production is increasing at the rate of 500, it means that dx by dt is 500. When production is 2000, it means that when X is 2000, find the rate of increase in the cost. So we need to find dc by dt. Here you can see this is the cost function, c equals to c by t, x equals to x by t. We can differentiate it, dc by dt. Here we will get dx by dt. We are given dx by dt, we can substitute it here and you can see this is what we can get. From here you can substitute here dx by dt is 500 and when x is 2000, you can get the change in the cost will be $1000 per week. Cost is increasing at the rate of 1000 per week with the production. Okay, now if production increases at the rate of 500 flash, we can find the rate of increase in the revenue. Now rate of increase in the revenue, dr by dt, we can take dr by dt of this function. If I take dr by dt of this function, it will be minus 0.01 into 2x dx over dt. Again you can substitute the values. We are given x, we are given dx by dt, and you can get rate of increase in the revenue dx by dt. Similarly, we can find the rate of increase in the profit, which means that we need to find dp by dt. So dr over dt minus dc by dt. We know dr by dt, we know dc by dt. You can substitute them here and you can get dp by dt. You can see it here. We previously found when x is 2000 dx by dt. So dr by dt is this and dc by dt, which is already obtained in the previous slide, and substitute them here and you can get what is dp by dt, rate of increase in the flash drives, rate of increase in the profit, which is 2000 of the flash drives.